Okay, today's assignment is April 16th, quadratic regression using a graphing calculator. So please go ahead and read this. Also read what we're going to do with the equation and with the data. But in summary, what we have is a situation where a rocket is launched, it goes up, we have 4 points that are given, and based upon those 4 points, we want to find an equation, a quadratic equation, because a quadratic equation we know goes up and then comes back down, as opposed to a linear, which just goes in a straight line forever. So in a situation where something goes up and then comes back down, quadratic equation is a great one for modeling it. And this is your generic form right here, y equals a times x squared plus bx plus c. This is a generic equation. It's called standard form, like it says. And if we have that equation, not only will we have these 4 points in time, 4 heights based upon time, we can also figure out different other heights of the cannonball, I guess, based upon the time, because we'll have the path of it that goes through it. So that's our goal today. And we're going to start with these 4 points here. Now what we're going to do is we're going to take those points and we're going to use a graphing calculator to run a regression, a quadratic regression it's called. Now, if you are in the class, then you probably remember not long ago, we used Desmos to enter these points in, and we gave Desmos a command, and it gave us an equation and a graph that was kind of nice, that allow us to figure out all the different values of any time, when the ball would be launched, what was the height of it, what was the maximum height, for example, how long did it take to get there, at what point did the ball hit the ground. So we were able to do that with Desmos, and it was very user friendly. You could just click on the graph. Here we're going to have to do a little bit more work, but it's another way to get the information, and it's going to be the way that we do on the test, since we can't use Desmos. All right, enough for my introduction. Now, what I'm going to do first of all is enter the data into a graphing calculator like we've done many times before. So please grab a graphing calculator, and we'll go over that. Okay, getting the data. So remember, from the sheet right here, we have the data. The first column, time, we're going to make our first column, which is kind of like our X column or our horizontal column. And our height is going to be our vertical, or maybe like our Y column. So enter that in, we go to stat 1, which is already on 1, and enter. Okay, the data is already there, but I'm going to show you how to enter it in. So if you get a calculator, you need to clear it out. So how do you clear out data in column? Use the arrow key to go up to the title things, the L1, L2. You hit clear and enter. So that's how you do that. And then you go to the other one, clear, enter. Now it's ready to enter in the data. So the first column, like I said, was the time. So 5, 10, 25, 30, 5, 10, 25, 30. Okay, then you use your arrow keys to go to the second column and also enter in that data. So I won't make you watch me enter all the data, but like 560 would be the first one, right? So I just go 560, enter, and etc. So I'll pause this and enter the rest of the data. Okay, so I'm back. I've entered in the data in both columns. You always want to go back and make sure that you've entered the right data. Now, if you were entering in the data, you don't need commas when you're entering it in here. If you saw the table, there was a comma, and there should be after the thousands mark, but you don't need that. You can just enter it without the comma. Okay, now we're ready to run the regression. So we hit stat calc. So we got to use this arrow to go to calc. And then we need quadratic regression. So we've done linear regression before, but now we need quadratic regression. So I can hit 5, and it goes straight to that quadratic regression. And then I hit, I got to scroll down to calculate, so I can calculate for me. And then I hit enter. And voila, there we go. So the output you get are A, B, C, and I'll talk about this later, but the output you get is A, B, and C. And what are those numbers? What do they represent? Remember, a generic quadratic equation is in standard form, is right here. Now, it gives us a y value based upon plugging in some number for x. Well, if we don't know what A, B, and C are, then we can't plug a number in for x and get a number for y. I mean, because what's 3 times b? Well, it's 3b, but that's not a number. So that means we need a number like A for A, B, and C. Well, check it out. Based upon those 4 points we entered, it's telling us that the values for A, B, and C are these numbers right here. So that means we can go to our assignment. So let's go to the first page of the assignment. Okay, the first page of the assignment. So we scroll down, and the A that we got for question number 1 was on there. It's going to be on the readout. The B and the C. So what are those? Again, A is -3, B 126, C 5. So that gives us those. Now, at that point, what can we answer now that we have the equation? Well, keep in mind, the equation is going to be y equals whatever that A is. So I'm going to write that down somewhere, and you should write it down on your sheet somewhere. Okay, so the actual equation that models those 4 points we got is going to be y equals, instead of A, it's -3x squared. Instead of B, it's 126. Instead of C, it's +5. Okay, so that's the actual equation that models the path of the ball. I don't have it right now, but the path of the ball that allows us to figure out, ooh, that this should be an X, by the way, my bad. Please put an X there if you're writing this down. You should write this down somewhere so that you can use this equation now that you've got it. So again, -3 would be that, B would be 126, C would be 5. There's one other thing we can answer really quickly. At what height was the ball launched? You may remember this from before, but the C is going to be, it's your y-intercept, which means that, okay, let me do this better. That means if you got a ball that goes up like that, it's going to be the starting point. So what is C? Well, C was 5, right? So that means the ball is launched at 5. So the rocket's not completely at ground level, maybe a little bit above when the ball gets launched. So it's at 5 feet. And so that would be the answer for number 4, okay? Now, I'm going to make another video so it's not so long for the rest of the questions, but then we're going to be able to answer, use that equation to answer questions for questions 5 through 9. So that'll be the next video.